Hello everyone, this is Savannah Betkowski, Project Assistant at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled, I've Completed My Water Audit. Now what? To give you all of an idea of where others on the webinar are tuning in from, we have prepared this map. You can see that we have attendees spread all throughout the country. Thanks to you all for joining us today. Attendees can receive a certificate of attendance for viewing this webinar. This webinar has not been submitted to licensing agencies for pre-approval of continuing education credits. AWWA recommends that you check with your licensing agency to learn about its criteria, rules, and what you need to do in order to receive credit for your attendance. It is your responsibility to verify this information with your licensing agency. If you need assistance in applying for credit to your licensing agency, please contact Education Services at awwa.org. For attendees who have an AWWA customer record, your certificate will be uploaded within 30 days of the webinar date. For attendees who do not have an AWWA customer record, you will receive an email from AWWA requesting you to create a customer record by a specific date to receive your certificate. If you do not create a customer record, you will not receive a certificate. This session is one of several webinars conducted by the Environmental Finance Center Network for the Smart Management for Small Water Systems project. The EFCN provides training and technical assistance to small public water systems in all 50 states and 5 territories to help local water systems achieve and maintain compliance with the Safe Drinking Water Act. And here you can see the various centers that make up the Environmental Finance Center. You can see that we have centers spread all across the entire country. And here you can see the areas of expertise that the EFCN focuses on. Workshops, trainings, and direct assistance are provided on asset management, rates and finance, leadership through decision-making and communication, water loss reduction, collaborating with neighboring communities, multi-funding, water conservation, management and finance tools and techniques, climate change resiliency, and workforce development. The EFCN also has a small systems blog where you can learn more about water, finance, and management through this blog. You will have the opportunity to subscribe to this blog at the end of the webinar. In addition to workshops, direct technical assistance, and webinars, as part of the Smart Management for Small Water Systems project, we are also creating a table that lists the major funding sources for drinking water infrastructure projects for each state and territory. And here's how you can access those tables. On the home page, please go to Resources and then click on Funding Sources by State. This will take you to a map of the country. If you click on the state you are interested in, you will find a PDF table of the relevant funding sources for drinking water infrastructure in that state. This table looks like the image on the left-hand side of the slide. For each funding program, it will include the name of the program, a short description, and contact information for someone who works in the program. Now, before I turn the presentation over to our speaker for today, I do have 2 quick polling questions for you. The first one is, what kind of drinking water utility do you represent? Please select from one of the following: a for-profit water utility, a local government, either a municipality or county, a non-for-profit, cooperative, or association, or another water utility such as an authority district or hotel, or you're from a non-drinking water utility. And getting ready to close the poll in 3, 2, 1. As you can see, it looks like we're a pretty close tie between a local government or a non-drinking water utility. And the second quick polling question is, what size drinking water system does your utility operate by number of people served? Please select from one of the following: very small, small, medium, large or very large, or from a non-drinking water utility. And getting ready to close the poll in 3, 2, 1. As you can see, the majority goes to a non-drinking water utility, followed by medium, and large and small water utilities are pretty close. At this point, I would like to turn the presentation over to our speaker for today. For our webinar today, we have Heather Himmelberger, Director of the Southwest Environmental Finance Center. We also have Dawn Nall with us today as our questions and answer moderator. Dawn is a program manager at the Southwest Environmental Finance Center. Heather, welcome, and take it away.
Okay, I'm just Trying to get my screen. Savannah, is my screen showing?
Yes, it is.
Okay, great. All right, thank you, and welcome everyone to our today's webinar that's titled, I've completed my water audit, now what? And this is series webinar 3 in a series of water loss webinars that we've conducted. I want to do a quick review here.
Change your display. We can see your...
Okay, hang on one second. Okay, did that fix it?
Yes.
Okay, sorry about that. All right, so we'll start with water produced minus water sold is our non-revenue water. So what we want to think is that we don't want to have the temptation to assume that we know the reason that the non-revenue water exists. So we don't want to assume that we have all the answers of why that non-revenue is there, what makes up that non-revenue, because we might make the wrong decision. So imagine that you have a car and it's not running well. There may be several reasons why that car isn't running well. Some might be small, low dollar issues. Some might be large, high dollar issues. So what would happen if we just jumped to the conclusion that it was my transmission that was the problem? So I took it to the car shop and I said, without investigating any further, my car's not running well. Go ahead and for $3,000 or $3,500 fix my transmission. When I get the car back, it still might be running poorly because maybe that wasn't the problem. We wouldn't do that with our cars. We would take it in, we would ask for somebody to evaluate the car and see what was going wrong because we wouldn't want to spend money in the wrong place. It's the same thing with our utilities. If we don't know the makeup of that non-revenue water, we may apply the wrong solution. So we don't want to jump to the end and say we think we know what's happening until we investigate it. And that's because non-revenue water includes a lot of things. There are 6 different types of factors of what goes into the non-revenue water that are shown there. And sometimes we jump to the conclusion that all of our non-revenue water is water leaking out of our system, or it might all be inaccurate metering, and that would not be accurate. So we want to make sure that we keep in mind that non-revenue water is 6 different kinds of things, and we want to be very careful to make sure that we're doing a thorough evaluation of our problem before we jump to the end and make conclusions. So we have to analyze the problem before we can address it. So the starting place is gathering our data that we would put into a water audit, and the data fits into 5 categories as kind of shown on the screen there. And we talked a lot about this in the first webinar on March 1st, 2017. That webinar is recorded and available on the efcnetwork.org website. So if you want more information about how to get your data and what the data gathering process is all about, please access that recording and listen to that for a more detailed description. A few highlights from that webinar are that the most important piece of data is the volume of water supplied to the system. And why that matters is when we think of the overall balance of water, all the columns add up to the same amount. So the column that sort of sets the standard is the volume supplied, and that has to equal the water being used for all these different purposes. And the real water loss is actually down at the bottom. So we're going to get the real water loss number by taking our water supplied, subtracting all the other uses of water, and then we will get the real water loss number. So if the number for water supplied is off, it's going to create a problem for our real water loss calculation. We also want to think about the master meter errors, which is another important factor. So we want to know if we've checked our meter itself, the meter in its installation, and the accuracy of any electronics, because that can have a big impact. Another important factor is the water that we sell to our customers, because that's going to be a big component of the water sold. So at the beginning, our data quality may not be very high. We might be a little intimidated about gathering the data. We might be missing pieces. Don't worry about that. If you start your audit and just jump into it, you can figure out where to make improvements and how to make it better over time. So just go ahead and start, and then that will show you where to begin improving for the next time around. So the water audit itself is using the American Water Works Association water audit software. The software is free. It's available on AWWA's website, the AWWA.org website. And you can get that by registering, which is a free registration, and then downloading it to your machine. You'll begin the audit by looking at the instruction page, entering some information there, then put your data in the data reporting sheet, and then finally you'll be doing a data grade. So each input that you put in, you'll give it a data grade to say the policies and practices that went into getting that piece of data. And the most important thing when you're doing your data grades is to be honest about what the data grade should be, because the right data grade is the one that accurately reflects your particular situation. You don't want to just arbitrarily give it a 7 or an 8 or 9 out of 10 without really looking at your system, because you will have an overconfidence in your data if you do that, and you won't know where to make improvements. Webinar 2 covered the data entry and the data grading procedure, and that's available on the efcnetwork.org website. So if you'd like to kind of go the step further, once you've got your data, how to put it in and how to grade it, please access that recording for more information. So let's assume that we've done our water audit. So what does the water audit tell us? There's 3 main components that we'll get out of the water audit. The first is a data validity score. The second is the value or the cost of water in different categories. And the third is the volume of water in different categories. So our starting point should be data validity, and looking at the data validity, because we want to start there before, again, that we invest any money or any activities, because we want to be sure what's going on with our audit. And the best way to kind of tell that is our data validity score. The higher the score, the more confidence we can have with the information we put in and the information we got out. Now, where can I find this data validity score? I would look on the bottom of the reporting worksheet, and at the bottom of the worksheet is going to look like this. So our water audit data validity score is going to be a score out of 100. So in this case, we have 57 out of 100 for this example audit. And that's telling us that, telling us information. And the screening range we kind of have set is greater than 50, you're kind of ready to move on to the next step, and below 50, you're not. So for the first example, 57 out of 100, that system is greater than 50. They can sort of be ready to move on to the next step. Doesn't mean they won't do anything more to address their data, but it means that they're kind of in a position where they can start doing more. And less than 50, you would want to stay with the data, with the policies and procedures that went in the data. Try to improve that and get above 50 before you go a whole lot further in the next steps. So again, actions to take if your score is less than 50. We're going to look at the suggested areas of improvement to try to make those scores higher. We'll review data and look for concerns in the data. If you're 50 to 70, we'll look again at the areas of suggested improvement. We'll begin some next steps, but we'll still review any data weaknesses to see how we can improve. If we're above 70, we'll look at areas of improvement again, and we'll review the areas that have lower data grades. So we might have a pretty good score at 70, but there'll still be areas that may have lower data grades, and those would be areas that we could still work on. The priority areas for attention are at the bottom of the reporting worksheet. It will give you the top 3 areas for your particular situation, and the data grades are not weighted equally, so it's going to give you the types of things that will have the most impact on your score, on your validity score. So the volume from own sources is often the first one up there because it is such an important number, and unless you have a 9 or a 10, it's probably going to be the first thing on the list, because that's where you'll have the greatest impact on the overall validity score. And then we'll give you the next 2 that will give you opportunities for where can I improve. You'll also have information in the grading matrix that comes with the water audit, and it will tell you, highlighted in yellow, what kinds of actions you can take to move to the next highest data grade for each of the data grades that you have in the system. And there's also a water loss control planning tab in the water audit, and it will tell you, highlighted in yellow, which area you're in. In this particular case, we were 57, so it's saying we are level 3 and is giving us suggested actions to take, And you can see that the lower your score is, the more they want you to stay with data handling. The higher your score, the more you can do with addressing non-revenue water. So if we move on to looking at the values and volumes, the dashboard on the water audit will give you some information about the values and volumes. So you have an opportunity on the dashboard to toggle between show me the cost of non-revenue water and the volume of non-revenue water. So one thing that's interesting to note is the value and volumes don't always match. So the highest volume doesn't necessarily mean it's the highest value. It really depends on your system characteristics, how much you charge for water, how much it costs to produce water. So in this particular example, the highest volume of water is this orange bar, and the orange bar is related to real water losses. The highest value is actually customer meter inaccuracies. So the value and volumes are not the same in this particular case. We're losing more revenue by the customer meter inaccuracies than we are through the real water losses. So we have to think about, what's more important to us, saving the water or increasing the revenue, because we may decide to take a different action depending on what our goals are and what we're trying to accomplish. Or we may decide to do one first before the other. Maybe increasing the revenues could help us address some of the water loss and volume issues. You will also in the water audit get some performance indicators. On this page it will give you things like the apparent loss, total volume, the real losses, the water losses combined. It will give you some information about the cost of apparent losses and real losses. And then we'll give you some metrics for operational efficiency, so real losses per connection per day or real losses per length of main per day. And we can use a screening range to kind of see whether we're falling within the range of validated audits. So some folks got together and looked at a whole bunch of audits and said once they had validated them, what was a typical range? So for real losses per service connection per day, it's typically between 20 and 200. And real losses per length of main per day is 400 to 4,000. Your utility will get one of these calculated or the other. You won't get both. So you can look and see if you're within the range of, validated audits. And what you can do with this is see where you are today, and you can choose a goal to reduce. So this particular utility is about 28. If they wanted to reduce the real losses, they could set a goal of maybe 25 initially or 20 initially and try to get that number down a little bit to reduce the real losses. There's also the infrastructure leakage index. We will not spend a lot of time talking about this today because small utilities typically don't have metrics that will allow it to be calculated. But if you have that calculated for you, the range is typically 2 to 10. So what actions can we take to actually address our non-revenue water? So one thing to remember is that there isn't one right answer for if I do this, my non-revenue water will be reduced to a very low extent and I'm done. You really have to have a whole toolbox of a bunch of different approaches to address the different kinds of non-revenue water that you face, and you're going to have to apply them in a phased-in manner, trying to decide what's the most important thing for you to do first, second, third, etc. But it's very, very important to realize that this is not a one-size-fits-all, one approach that will address water loss and take care of the problem. So they have three main areas for non-revenue water, three main categories. The unbilled authorized consumption, apparent losses, and real losses. So we'll go through each of those and look at some things you can do to address each of those. So when we talk about unbilled authorized consumption, these are folks that we're allowing to use the water but we're not billing. It kind of falls in two different categories, those we meter and those we don't. So the metered installations are typically those permanent uses of the water, a building, a park, something like that where we're sending water but we're not sending a bill. And unbilled, unmetered uses, what we want to have there would be flushing that we do, firefighting, things that we wouldn't typically meter, but we're just going to do on a non-permanent basis. We might move around the system and have to do flushing. So you want to think about what constitutes that authorized unbilled usage at your facility. How much firefighting do you have? How many public buildings do you serve water to that you don't bill? How much flushing do you do? How often do your fire company folks come out and flush meters and test them? Do you have any parks or golf courses or anything like that that you provide water to that you don't send a bill? The big issue is, do you meter all of your permanent uses? If you don't, you really want to install meters for several purposes. One is to understand in your water audit how much of that authorized unbilled use is there. You also want to make sure that people are using the water efficiently, because again, these are folks who aren't being billed for the water, so there's no price signal for them to be more efficient or conserving with the water. And also, if there's any problem, such as a leak, reading the meters on a routine basis can alert you that there's a problem leak-wise, and you can go fix it. So if you install the meters, you want to read them regularly. So if you read meters monthly, you want to read these ones monthly as well. If you read quarterly, you want to read them quarterly. So you want to be on the same cycle of reading all the other customer meters so you can gather that information about what's going on at your unbilled authorized uses. And then you want to think about, are there ways that you can estimate those non-permanent uses? So that flushing, the fire flow, fire hydrant testing, that type of thing. You can use a default value in the water audit, and probably to begin with you would use that default maybe even for a couple of years. But after that point, you'd want to find ways to improve the quality of that data and get a better estimate of how much water is being used in that manner. So think about ways that you could maybe temporarily meter flushing, count how many hydrants you flush, how long you flush them, that sort of thing, to try to get a handle on how much water you're actually using in this non-permanent way. With that information, you can figure out how much water by volume is authorized and unbilled for each of those uses. So how much do I put on a park? How much do I put on a ball field? How much do I send to City Hall? How much do I send to the airport, etc.? And then you can figure out the value or the cost of each of those by using your customer retail cost. Dollars per 1,000 gallons could be applied to each of these, so you can tell how much money and how much water is going to each of these uses. A couple things you can do with that information. You can share the value with the entity that's receiving it. So if, for example, you're sending it to a building, you could share it with the folks in that building or whoever manages that building that, hey, you guys have used this much water, it's cost the city this much, or you've received this much benefit from the water. And that would give them a chance to look at, are there ways that we could improve upon that? Kind of gives them a little bit of signal as to what the benefit received is and how they might be able to help you by reducing uses. You also want to make sure it's transparent, that the governing body knows what each of these uses are and can make decisions about should any of those uses that are currently unbilled and authorized, should any of those be changed to billed authorized uses? So is there any of those customers that currently receive no bill that should receive a bill? And they can really decide which ones should remain and which ones should change. So in summary, we want to know what is authorized and unbilled. So we want to know what falls in that category. We want to estimate the values and volumes of each of those types of uses. We want to be transparent so that we can determine if any of them should be converted to billed, or to be aware of how much water that is, and maybe there needs to be a transfer. If there's a lot of government uses, maybe there needs to be a transfer from one government use to another. And then meter all permanent sources and then estimate the non-permanent ones as best you can to be able to provide that information in the audit in the future. It's important to remember that someone is paying for the water that's unbilled, so you want to have that be as efficient and effective as possible, because you want to not have a huge unbilled amount of water, because that just means the other customers have to pay more. When we go into apparent losses, we have three categories there: unauthorized consumption, customer meter inaccuracies, and systematic data handling errors. So starting in this area, we have what we call the 4 pillars of apparent loss control. So we look at customer meter testing and replacement. We look at theft deterrence, so trying to keep people from wanting to steal. And then 2 types of quality control with our data. So when we get our meter readings and transfer those to the billing system, trying to make sure that that process is done well, and trying to look at our billing procedures when we transfer that stuff to the archives. So if we look at this diagram, we have our existing apparent losses in the outside blue box. We have unavoidable apparent losses, meaning that it is kind of assumed you can't get rid of absolutely everything. There's just going to be some amount of apparent loss that no matter how much you try, you're not going to get rid of it. And then there'll be some that's economic to reduce. So you're just kind of looking at, well, where can I spend my money wisely to reduce the amount of apparent loss and not go overboard with investing way more than the benefit I would receive. So if you look at customer meter accuracy testing, this is a pretty complicated thing because you have a lot of meters. They could be commercial, they could be institutional, they could be residential, they can be different sizes, different amounts of uses. So it gets to be a much more complicated thing than looking at your master meters where there's probably a lot fewer of them and it's a little bit easier to run a meter testing program for that. But you can do testing of your customer meters, and they can be done by an outside firm, or you can do it in-house if you have the right equipment. But you want to make sure you have skills and ability to do the actual meter testing. You don't want to take this on if you don't have that capability. And the accuracy can be done over time because it's really hard to kind of get out there and do a full-bore program right off the bat. So you might choose to test certain meters at the beginning and then build in some other phases of the program. So think about ways you can set goals and which ones would you want to do first. Would you want to choose the ones that had the highest volume? Would you want to choose the ones that had the most complaints? Would you choose a certain type of meter or a certain size of meter? Anything like that could be a starting place, and then you can always add in other categories later on. The AWWA M6 guide is a good guide for, selection, installation, testing, and maintenance of meters. So if you want more information about meters in general, there's some good information in that guide about, how to do the testing procedures and that sort of thing. You can also, talk to your neighboring utilities and that sort of thing to try to ask them, how have you done meter testing? Who have you worked with? To try to get options for how you might do it. You might also check with a larger utility. Many of the large city utilities have meter testing equipment, and they may know a lot about how to do meter testing, or may even be able to work out a deal where you can pay them a certain amount of money to do the testing for you. So just look at all the options available to you and try to design a program that best fits your needs. One example of, having done meter testing in this small community, you can look at how the accuracy data could plot through, plot versus the flow through the meter, the total flow. And you can see that the accuracy really started to drop off after 1 million gallons. So in this particular utility, if they were to find that, whenever they did the testing, 1 million gallons seemed like a good breaking point, that at that point the meters start to get a lot worse in accuracy, they could just design a program that says every time a meter hits 1 million gallons, we're going to take it out and replace it. So it can give you good information for how to improve your program and get benefits over time. In data handling errors, we're looking here at things that we do that cause errors in water auditing. So one example is, what if you have an archive system in your billing software where a new customer comes in July, and we take the data from January to June for the old customer and archive it. So from the billing perspective, that may be fine. We don't need the other information anymore. It's a different customer. We don't care. From a water auditing standpoint, that makes a huge difference because we lost a whole half a year of flow that won't show up when we print out the totals from the billing software. So if we have situations like that, that can be really problematic for us, and we need to find another way to gather that information. And especially if you have a lot of customers that switch during the year, that could be a huge error in your data. Another possibility is if your utility rebates money back after a large household side leak and says, okay, well, 100,000 gallons passed through your meter, but it was a leak. You've agreed to fix it, so we're going to rebate some of that back. Some of the billing softwares that we've talked to utilities about require you to actually change the quantity to get the lower bill rather than changing just the amount of money you're going to charge them. So in that case, you will have lost a whole bunch of water that actually passed through the meter, and you need to account for that in your software. So somewhere you need to keep track of that water. When we talk about theft deterrence, there's several different things you can do, and how much you put into this really depends on the extent of the problem you have. Some systems have a lot of problems with theft, other systems not so much. So depending on what you see out there, how creative your customers are at trying to get around the rules and steal water from you, you would invest more or less depending on what you're seeing in your system. But things you can do is, if people are used to you meter reading on a particular day of the month, if you still have the case where the meter reader goes out and does the readings themselves, and maybe they come on the first Tuesday of every month, maybe you can come on the third Thursday and just pop the meter lids and look at some of them just to see if anybody has tampered with the meters, taken it out, etc. You can do a meter inventory where you look through the entire system, make sure every house has a meter, that you can find the meters, that they're all operating. If you have hydrant thefts, one possibility is a locking hydrant where the fire department would have a key, but everybody else wouldn't be able to access it. If you go down that path, you have to work carefully in collaboration with your fire departments and make sure that they're okay with it. You can color hydrants so that customers are only allowed to take water out of hydrants that are colored a certain color, and then you inform your customers what to look for. So if you see somebody taking water out of a yellow hydrant and they should be taking it out of a green hydrant or something like that, that the customers know to call in. So working in conjunction with your customers, you can reduce the theft that way. You can have penalties for theft, and if you really want to ensure that nobody is hooking up to a hydrant anywhere, and you can tell your customers anytime you see somebody hooking up to a hydrant, let us know. You could put a hydrant in some kind of a locked facility that says this is the only place you can get water, and then just have the eyes of your customers kind of looking out to see if anybody is hooked up to another hydrant. So again, how much effort you put into theft really depends on what kind of situation you have. Moving on to real loss, which is what oftentimes people focus on the most and forget the other two major categories of water loss, is the real losses, that leakage on mains, service lines, and overflows, and leakage at storage tanks. These are important components, but we can't forget the other two because they may be equally large or even larger in your particular utility. So when we think of real loss, there's three kinds of leakage that we talk about. One is background leakage. This is sort of weeps and seeps at fittings and joints and that kind of thing. Then we have unreported leaks or hidden leaks. These are leaks that we do not see on the ground. There's no evidence for them. We can only get them by finding them. And then we have our observable or reported leaks. So these are things that we can find by seeing water on the surface or seeing vegetation where it doesn't belong, or sinkholes or something developing that lets us know there's a water leak down below. The quantity of unavoidable or background leakage can be determined through system characteristics of length of mains, connections, pressures, that sort of thing. There is a range at which your utility has to be within that range for the equation to be valid, but the water audit software will calculate this for you if you're in that range, and if not, it's a little bit more difficult to figure out the unavoidable or background leakage. So how much can I actually reduce my real water losses? If we think about this green box being the current annual real losses, so this is the total losses, and this value could be obtained from my water audit software. And then I have my unavoidable real losses that, again, are obtained by looking at our system characteristics and using that equation. The difference between the two is our potential for real water loss reduction. So we could reduce from the green box to the red box in theory. However, there's another level where it would be economic to reduce it, And this will be bigger or smaller depending on your particular situation and how much water costs to produce and that sort of thing. But if you're wanting to look at what would be economical to do, it would be the yellow box. What is theoretically possible is that purple hatched area between the green and the red boxes, but in no case will you ever be able to reduce the current real losses to zero. That is not a goal that anybody should set, because you're always going to have some losses in your system. It isn't a realistic goal. You're just trying to reduce from where you are to get a little bit better. So we have 4 pillars of real loss control. The first one is improving that leak repair time. The second is infrastructure or asset management. The third is pressure management. And the fourth one is finding our hidden leaks. So if we respond to known leaks faster, we can look at a series of leaks here. These are just example leaks of the amount of water leaking and the amount of time over which they leaked. And you can see that a long duration leak of a low amount of water actually can produce quite a bit of water loss, way more than a high intensity leak over a short period. Let's say we cut the leak time in half and we did them in half the amount of time that we were doing before. In just this case of these 5 particular leaks, that would save 1,176,000 gallons. The point being that there is a savings to be had. If you can get out and fix leaks faster, you can save water, time, and money. So you would have to make the case for needing additional resources. The reason you're probably not fixing them faster is you probably don't have enough personnel, equipment, supplies, etc. to be able to do that. So make the case for what would you need to do it faster, what is the cost of that, what are the benefits of doing it, and increase the speed to the extent that your benefits, both economic and non-economic, outweigh the costs of doing it. And there is a pretty good case to be made if you have a slow response time to reported leaks. With asset management, we're talking about the current state of the assets, level of service, what you want your assets to do, criticality, which assets are more critical to sustain performance, life cycle costing, how the assets will be handled throughout their life, and long-term funding. So if we apply that to the water loss situation, we're really looking at our pipes. So we want to gather data on our pipes. We want to look at type, size, installation, etc. And we would want to have some kind of map where we could store that information. We also want to make a best estimate of the condition of each of our pipes and the useful life remaining. So how much longer will that pipe be able to be in service before it's no longer going to convey the water the way we want, or the break rate is going to be too high, or something like that. So using our inventory and the cost, we can estimate a cost of replacement of our pipe. And this gives us an idea, combining that with our useful life remaining, we'll say how much money would we need to be able to replace our pipe. So if I think this much pipe is going to be lasting another year, that costs so many dollars per mile, this is how much money I would need in that year, or 5 years, 10 years, 15 years down the road. So use the best data available to estimate your costs and make that estimate. Set some goals for what you really would like to have in terms of number of breaks per mile of main per year, or the gallons of real loss per mile per main, which is given to you by the water audit. When you're looking at criticality, you're looking at what is the likelihood or probability that an individual pipe will fail, and what is the consequence if the pipe actually does fail. And you want to plot it as the pipes with the highest risk are those that are very likely to fail, and if they do, it's a bad consequence. And you really want to think about those pipes being the ones you want to replace over the pipes that are unlikely to fail, and it's not really a big deal if they do. And that gives you information looking at the criticality of which option you want to take whenever there is a pipe break. Do we want to repair it, rehabilitate it, or replace it? So we typically would repair low-risk pipes and probably replace our high-risk pipes. You know, as we're looking at the different options, if it's a really high criticality pipe, that's one we're going to lean towards replacement, and low criticality we lean towards repair. We can also collect data on pipe breaks. This is really good information to have. There's a recent study done by the Water Research Foundation that says collecting pipe break data is really one of the best ways to tell how much longer your pipe is going to last. They've done a pretty thorough analysis of different kinds of factors and decided that age was not a very good factor in determining when pipes should be replaced, that break data was a much better factor. So collect all the break data you can in terms of where it happened, how it happened, what type of pipe, the condition, anything that you can, and store it in a way in which it's easy to retrieve it. Eventually, all your pipe will need to be replaced, and as we said, the higher criticality probably sooner, lower criticality later, but only replace the pipe that needs it. The most expensive option for water loss control is really pipe replacement, so you really want to be judicious about how much of that you do. In pressure management, what we're looking at is pressure affects unavoidable losses. It actually affects all of the types of losses. As the pressure goes up, the losses will go up, and as the pressure goes down, the losses go down. So look for options for pressure reduction to see if it's possible to operate your system at a lower pressure. You wouldn't want to do this without talking to your engineers and making sure that indeed it's okay for you to reduce the pressure. But if there are options to do that, it could really save you water. And you can also look for options to reduce pressure surges and water hammer in your system, because that's another way that pipes break. So anything you can do to help your pressure is a good thing to do. You can also find hidden leaks as another method to deal with real water losses. So you can find hidden leaks by proactively looking for them. And you want to think about what the parameters are in your system, what type of pipe, how much pipe, and what type of contact points you have, because that matters when you're thinking about leak detection. You're going to have to listen to your pipe through these contact points, through meters, valves, hydrants, that type of thing. And so you need to know how many of those you have, how spaced apart they are, because the closer together they are, the easier it is to hear a leak noise. The further apart they are, the harder it is. And thinking about the type of pipe, it works a lot better on metallic pipe than plastic pipe. So as you're looking at your system, do you have metallic or plastic? Do you have a lot of points, few points? Because you could spend a lot of money on leak detection and find out that it's not going to get you the results you want. One utility was almost brand new PVC system, assumed that everybody had to do leak detection, did leak detection, didn't find any leaks, thought that the leak detection company was bad, did it again, didn't find any leaks. And the situation was that they really didn't have the kind of system that would leak to begin with, and it wasn't the type of system that you were likely to hear a lot of leak noises anyway. So you really want to think about it before you take that on. And another thing to remember is that water is only saved through fixing leaks, not finding leaks. So somebody can go around and do a leak detection survey, but if you're not going to dig up the pipe and fix the leaks, you don't want to invest in the leak detection survey. You really want to match the two up. You want to match up looking for leaks and fixing them. You have the option of doing an active leak survey where a person goes around and listens, or a passive one where you have a device installed in your system that listens for leaks. Both types are based on leak noise and listen for leaks, and both of them have the potential to have false positives where it might hear something thinking it's a leak and it isn't actually a leak. There are some tools that you can use, things like ground microphones that help amplify the sound, and leak correlators that they're a little more expensive technology, but with training that can be a good way to pinpoint your leaks. You can survey the entire system, part of the system, or a sample of the system, and you can use contractors or in-house personnel, and you're kind of looking at whether you can train up staff, how much you're going to be doing with the staff. You don't want to spend a lot of money on equipment and training if you're only going to do this once every couple of years. You probably hire a contractor in that case. But you have either option. With the passive technologies, you can do permanent or semi-permanent deployment. You can have devices on all of your valves. You can have them on some of them. You can lift and shift them around your system. So there's a lot of different options for how to do passive surveys. Which one you choose really depends on, the cost of getting those little devices and putting them in your system. The fact that those devices listen at night and the people are probably out more likely to be out during the day, and how difficult it is to do a night survey. The types of leaks that you have, the types of pipe and that sort of thing. So there's a lot of different reasons to pick one over the other. So the bottom line on looking for leaks, look for what you can fix, match the technology and techniques to your particular system, choose the activities that are going to meet the goals that you've set for your system, and match your activities to how much money you have to spend. So applying the tools from the toolkit, we want to start out again with performing our water balance to see what non-revenue water we have. We want to look at our data validity, make sure it's high enough, and see if there's any issues with our data. Look at the volumes and value of non-revenue water. Prioritize activities to address the values and volumes of non-revenue water. Here's an example of a toolkit for utility. This is a good listing of tools. There are actually some other tools you can use, but this is 10 different tools that talk about, how you can use them to address the different types of non-revenue water, and then what the cost is of employing those tools. So this just gives you some idea of the fact that there is a lot of different tools you can use, and you should not be focused on just having one tool or another. So difficulties with implementing a whole water loss reduction program. It is definitely more interesting to folks to design and build something than to fix underground pipe. It's not a sexy program. You don't get to cut ribbons. So it's a little bit more difficult to get the interest of your elected leaders and your public because it's just not that kind of program. One of the biggest things is selecting what you do based on your preconceived ideas rather than looking at actual data. Underestimating the time and resources and difficulties with implementing a program. Partial implementation, which leads you to not meet your goals, and then failure to mobilize all the necessary resources. So all of those things are important factors. So what could you do at your own facility? Well, the main thing is if you haven't done a water audit, definitely start there and determine the nature of your non-revenue water before you do anything else. And then if you have done a water audit, look at the validity, see where you're at, see if you need to stay in the validity stage before you move on. If you're above 50, look at what activities you might want to consider implementing. If you're below 50, stay in the validity stage. And then looking at your values and volumes of non-revenue water, look at the tools that can be used to address each of those and try to figure out which ones are the highest priority for your system to address the needs that you have. So with that, we will open up to questions. I will check with Dawn. Have we had any questions come in?
We do have, yes, we do have a question. So the question is about determining criticality for the water systems, and it says, I'm going to kind of paraphrase, I think. So they find that determining criticality for the water system can be difficult, that systems look at what the critical point is differently, sometimes at the individual customer point of view, sometimes a political point of view, versus the system overall. So they're asking if we have any examples where a water system found everything to, determined everything was critical and then had to redo the evaluation, or if there was an example where there's a political criticality focused evaluation. So they're looking for examples of how to handle those situations.
Yeah, the one that I've heard of, I have a colleague in New Zealand that I work a lot with, and he has talked about a lot of utilities that actually have sort of an in-between situation where if you rank probability of failure from 1 to 5 and you rank consequence of failure from 1 to 5, and then you multiply those together to get criticality, which is our typical sort of approach, a lot of systems will just pick 3 for everything. And then all the criticalities come out 9. So it's sort of the same situation but for a different reason. And that is not helpful. So it's not helpful if all of your pipes are highly critical or all your pipe is, 9, moderate criticality. It doesn't help you. What you're really trying to do is be as objective as possible in using the tools. So what we usually try to do, because sometimes politics does play into it, and I have seen that happen where things get political, is the more objective the measures can be, So if you base probability of failure on, say, past break history, for example, and you say, okay, if it's broken once in a segment, and you can make the segment whatever size you want, if it's a mile or, quarter of a mile or something like that, and say, okay, if it's broken once, we'll give it one factor. If it's broken twice, we'll give it a different factor. And you can have a bunch of these different factors to say what the probability of failure is. You could use age, although, as I mentioned, it's not the best determinant, but that could be one factor. So you can look at all these different things and say, okay, if it's a pipe that's this old with this many breaks, this type of pipe, this kind of condition, we're going to give it a 1. If it's this other, we're going to give it a 2. And try to be as objective as possible for how you get each of those numbers. You'll have a much better criticality. And the same thing on consequence, looking at objective measures. So is this a pipe that's a major transmission main? Is this a pipe that serves less than a certain number of customers? How many critical customers are on this pipe? So say a hospital, school, whatever. And you try to determine as objective a measure as possible for each one. So looking at the factors that affect probability, the factors that affect consequence, and trying to say that we're going to be as absolutely objective with what gives it a 1 through 5 on each one, because you want the criticality to be as absolutely reflective of the system as possible. And when you do that, that gives you the best opportunity to improve the situation. Systems that arbitrarily give something high or low criticality are not going to have the improvement they want because they've skewed the data, and it doesn't help them. So you really want to have these objective measures, and we have worked with utilities to try to make the measures more objective and look at things that prevent it from being as political or skewed in one way or another.
All right, they have asked, a question has come in, could you show the slide again with the ranges of performance indicators for audited utilities?
Sure, let me just, let's see, oops. I'm sure this is not the most efficient way to get there, but it will get us there. Oh, there we go. Okay, so now it should be on the screen. And then the only metric that is not on this slide was just that 50 metric that, if your validity score is above 50.
And another question, how would a utility determine goals for water loss performance, considering you mentioned using real loss per mainline mile and determining real loss or mainline repair replacement?
Can you just repeat the beginning part then again?
Sure. How would a utility determine goals for water loss performance?
So what I would suggest is you start by looking at your metrics, see where you are, see where the value and volumes are, and then set goals that best address that. So I know a utility that has used like real losses per service connection per day and has set a goal based on where they are. They set a goal that reduces that number. So you don't arbitrarily want to pick, say, 20 as my goal. If you're at 200, that's going to be really hard to reduce it. So if you're at 200, you would want to pick maybe 180 or 150 and try to keep setting a goal that reduces you from where you are to a lower number. Or if you have real losses per length of main per day, reduce that number from where you are to a smaller amount on an annual basis. So what is my goal? Do I want to reduce that number by 5% or 10%? So what would that be if I'm at 30? What would 5% less be? And then you got to look at, well, if I'm going to reduce real losses per service connection per day, I have to have activities that would reduce real losses. So that's not going to happen unless I implement tools that reduce real losses. So if I feel like my real loss per service connection per day number is a little bit too high, I would have to take on things like fixing breaks faster, doing leak detection, reducing pressure, things that will impact the amount of real water that's leaking. Otherwise, setting the goal alone won't get it done. You have to actually take on activities. You can also use the volumes of apparent losses by category or real losses by category and just say, I'm going to try to reduce those volumes, and you can set goals for particular apparent loss categories as well. What we don't want to do is, even though the software provides it, there's a percent by volume of non-revenue water that's provided in the software, but that metric is going away. It's kind of a bad metric because it can be misleading. So two systems can have the same percent by volume, but can have very different characteristics. So one of those might be a lot of unbilled authorized usage. So it's non-revenue, but it's not leakage. Another system could have really high leakage. A third system could have really high apparent losses. And when people see that percent number, they're automatically jumping to, this is a lot of water leaking out of pipe. So it can be a little bit misleading of a metric. So that's not the best one to use. There is a percent by cost metric. That one is a little bit better, and that one will remain in the software. And the other reason the percent by volume is not used is if people do a lot of conservation, the total amount of water can go down, while maybe the real losses are actually staying the same, but by percentage it's going to look worse. So you have to be really careful that you're not doing things that kind of mislead people or are in the wrong vein. So using metrics that are more like the loss per main per day or loss per connection per day or the actual amount of apparent losses by category, those are better metrics than picking something like the percent by volume.
All right, we have a question and an example specific to the system, so I'll tell you the example first and then ask the question. So he says that he's been using a pipe replacement based on age for AC pipe of 50 years of life. And most of the smaller AC pipes do have a break history, but the larger than 12-inch have been break-free for more than 50 years. Most of the larger pipes are transmission mains and are critical, but do not have the break history causing losses. And the question is, should you not use age at all for pipe replacement?
My suggestion is age is not a good proxy. Your history with that pipe is much better. So you're clearly, in that example, they're clearly seeing a difference based on pipe size, which does seem to match other places' practice that, you know, people who've done research do see a difference between small diameter pipes and large diameter pipes of different kinds, and they will see different break histories, large versus small. So if all you do is pick age and don't base your stuff on experience, some pipes you'll replace too late, some pipes you'll replace too soon. So if they're doing really well, then you're really not wanting to take them out until they're starting to be problematic or until they could be problematic. So 50 years may not be long enough for the ones that aren't showing any kinds of problems. And let's assume that you have some information about condition. You can always do analysis. The companies can come in and kind of put a piece of equipment through your pipe to look at what's happening on the inside. If it's a pipe that you're really worried about, they can come and do some analysis for you. The lower diameter stuff, maybe you're waiting too long, and if it has a really high break history, you might want to replace that sooner. So it's much better to look at your actual experience, see what the condition of your pipe is, see how it's performing in different parts of your system, and base the replacement on your experiences in your particular system instead of just choosing an age, you know, as an arbitrary way of doing the pipe replacement.
All right, I think we have a couple of poll questions and some information for our participants.
Thank you, Dawn. So quickly before we end today's session, I do have 2 more quick polling questions for the attendees. The first one is if you would be interested in subscribing to the Environmental Finance Center blog. If you want to sign up for the blog but do not have the opportunity to submit your polling answer right now, you can sign up for the blog on the efcnetwork.org website. Getting ready to close that poll in 3, 2, 1. And the second polling question is, if you are a small water system of 10,000 or fewer people served, would you be interested in receiving in-depth technical assistance? And again, if you're unsure about technical assistance or do not have the opportunity to submit your answer today, please review the technical assistance form on the efcnetwork.org website. And getting ready to close that poll in 3, 2, 1. And lastly, in the chat box, there is a quick survey going out. If you could just take a few minutes to tell us about your thoughts of today's webinar, we would appreciate it. And also the AWWA CEU assistance email is also provided in that chat box. Heather, I just want to thank you for the in-depth look at what to do with a water audit once it is complete. And Dawn, thank you for moderating today's question and answer section. And thank you to all the attendees for joining us today. Heather, I'll throw it back to you for any additional closing comments.
Sure. Well, first of all, I'll apologize for the initial disruption in the presentation, and I thank everybody for being here today and participating in today's webinar. And if you've joined us for any of the other two, thank you for being part of the series. We did have some questions that were submitted in the first two webinars that we weren't able to get to. We will send those results out, or those answers to the questions out, to everybody who attended any of the three webinars. And if you have any additional questions, feel free to approach Dawn or myself with any of your questions about water losses and water auditing. And again, thank you for your participation today. We really are glad you were here.
Have a good day, everyone.